How do I make sure that my code is correct by construction? How do I make sure that I cannot represent states in my code that should never be represented, that are incorrect or invalid in some fashion? What does this even mean in the context of writing Python code? Well, I'm James Powell, and that's exactly what we're going to cover in today's session. Today, we're going to talk about a different notion of correctness. Not correctness from the perspective of using tools like PEP 484 type hinting mechanisms, not correctness from the perspective of testing, and not correctness from the perspective of data analyses, but correctness at the level of your code from the perspective of mechanisms available within the Python language to ensure that if you write the code is guaranteed to be correct. Specifically, today we're going to talk about things like properties. We're going to talk about metaclasses, build class, and init subclass. We're going to talk about class decorators, and we're going to talk about an overarching set of concepts, a premise, and some terminology for how to think about correctness a little bit differently. I will warn you that if you have questions about this session and you happen to ask them in Discord, I may or may not write a 20-page answer for you. This happened to one of our Discord participants just the other week, so do feel free to share your questions. Whether they're big questions or small questions with us in Discord, it is a fantastic opportunity for us to come together and to really think very deeply and very thoroughly about all of these topics and how they can affect our work, as well as allow us to write better code. But with that said, why don't we jump right in? You may have heard people say things like make invalid states unrepresentable. And what they mean here is in the program, you want it to be impossible for you to have data entities that are invalid in some fashion and could then subsequently lead to errors in your code. For example, let's say we're doing something with our star trader. And in our star trader game, we have different players that are trading different assets at different locations in the universe, and their goal is to become a merchant prince to make as much money as possible. So it stands to reason that as part of this program, somewhere we want to represent an individual trade. You purchase something in some quantity at some particular price. Now here you can see we're removing the idea of what you're actually purchasing. There's no representation of the asset, since the asset itself is probably either some enumerated value or it's probably some kind of string value. The core of what we're going to represent is maybe some price and some volume. And things like the asset may only be used for example, grouping to figure out what your position is. Now, if we think about this data, we can see that probably if we're to adopt a sign convention where you can trade in a positive or a negative quantity to represent a buy, a positive quantity, or a sell, a negative quantity, then it stands to reason that the volume is a signed quantity, but the price is an unsigned quantity. In other words, there's no such thing as negative $32. There's only, I sold something at $32, a negative value with a positive 32 as a price. And so here you can see that I have written a little bit of code using a data class, and in the data class's post init, I have ensured that you cannot create an instance of this class where the price is negative, where the volume is 0, because that might lead to some problems downstream. We might always assume, oh, the volume is non-zero. We might divide by this value. We might do something else with this value. And so that's also illegal for us to represent. And I might even add in a warning. Often it's the case that when we do these kind of trades, we might need to trade them in lots of 100. And so here I might even warn somebody if you have an odd lot. And so this means that if I try to represent a negative price, I'm unable to construct a piece of data of this type. If I try and create an odd lot, I just get a warning, but that still is allowed. And if I try and create a 0 value, well, I get another warning here. I've made it impossible for me to represent a trade object that is invalid by these two criteria of invalidity. Now, that I've made it impossible for me to represent this by constructing it doesn't mean that somebody cannot come in and do something that they're not supposed to do. For example, after I construct this thing, set the price to a negative value. And then that might break all of my assumptions, because otherwise I'm assuming at any point after this definition point in my code, any use of this trade object will conform to those two guarantees, meaning if those guarantees have subsequent correctness implications, I'm doing a division operation, I'm doing a multiplication operation, I'm doing some kind of operation where I assume that those two guarantees are held, well, I can be certain of that. But if I mutate this thing, well, I've just eliminated any guarantees. This may be why many people might say, you know what, you should make this thing immutable. Because when you make the data immutable, that means the only time you have to check it for correctness is on construction or on definition, and ever after, there's no way to change the data, so there's no way for the data to become invalid after the fact. And so I may make this a frozen data class. And by making this a frozen data class, I don't add in a check if you change the price. I just make it impossible for you to ever change the price. And so the only way, the only route to a valid construction of this thing is by passing it in here. And of course, we have our check there. Now, I will note that when we talk about things like immutability, we do have to take into account that there are limits of control in Python. In Python, typically when we talk about things like immutability, when we talk about things like constness, or when we talk about the visibility of something, whether it's private or public, we're really talking about what we convey to other users and what might be caught in a code review. We're not talking about what is strictly enforced by the interpreter itself. Because even if I happen to make this thing a frozen data class and immutable, nothing stops somebody from sidestepping this by doing an object set attr. And in fact, these two lines of code might not even immediately flag in code review, since this is the syntax that we're encouraged to use in the post init if, for example, we need to make subsequent modifications to the data class on construction. And so it might take a moment for somebody to say, hold on a second, that object set attr is not in the post init, it's at the module level. Oh, something's going wrong here. Let me catch you and stop you. And in fact, for those of you who've seen the presentation that we've given on the limits of control in Python, this presentation called Because You Can Run, You Can't Hide, well, you know that we're not able to strictly lock this thing down, but we can pretty much give some advice, we can give some guidance to users. Please don't do this, and everything will be fine. So there's, of course, some limitations here. Now, note that this approach is not always appropriate. In fact, when we talk about correctness, we can talk about different, I should say, enforcement approaches to correctness. We can talk about a static enforcement approach. This is our by construction approach. And I can talk about a dynamic enforcement approach, maybe an approach by some predicate. And it may seem like the static approach is always the approach you want to take because it'll catch errors immediately, it'll make things unrepresentable, but there's a little bit of nuance here that we need to keep in mind. Here's what I mean by the static or by construction approach, the dynamic or by predicate approach. Here, I have two implementations of the same class, and in the first one, on construction, I make sure that this value is not a zero value. Now note, I picked these examples purposefully because you can think that if we were to just throw our hands up and say, let's just leave this to our type hinter, let's leave this to MyPy or Pyre or a PEP 484 compliant type hinting mechanism, well, typically they won't be able to capture this type of detail, that the value cannot be strictly zero, cannot be a specific value, but can be any other integer value. And I can pretty much check for this invalid either on construction and perhaps even make this thing frozen, or I can add in a predicate. I can add in here a property that allows me to represent invalid data, but then ask, is this data valid? And you could think that everywhere subsequently in the code, I might say, if object is valid, do something, otherwise do something else. Now, it's pretty obvious from this latter example why it is that we may not want to do this. If we do not diligently check if this object is in its valid state every time we perform some operation, it could be very easy for some incorrect code to slip in. For example, whatever is happening here, maybe we do a 1 divided by object.value, and of course if that's 0, this is a zero division error, it's a domain error. Well, if I forget to add these checks in here, you can say, I'm not certain that that code is correct. It really depends on whether this object is in its valid state or not. And so the benefits of the by construction approach should be obvious. We don't have to diligently check at every use point in our code after the construction of this object whether or not this is valid or not. However, understand that it is not the case that this predicative approach is strictly worse than the constructive approach. Because, well, let's say we have a user who's coming to us and giving us some information, and we need to capture that information. Do we really want to tell that user, I'm sorry, this one field is invalid. I'm going to throw away every other piece of information that you've given me. Think about when you go to the doctor's office and you fill out a form. There's almost always some field on that form that you filled out that just isn't applicable to you. It's not applicable to your unique circumstances. It's not applicable to how you pay for your health care, whatever the case may be. And you talk to the receptionist, and the receptionist tells you, oh, if that's not applicable, just scratch it out, or put an NA, or just put a squiggle, or just put 0000, or we have a special code that we put into the system to indicate that that field is maybe on the form that we printed out, but no longer is something that we even care about collecting. In some places, I've even seen them pre-fill those fields just so they didn't have to reprint all of their forms. The reason they do that is they definitely don't want to say, I'm sorry, you might be bleeding out, but I can't see you because this one field is invalid. And in a very similar sense, when somebody is providing you information for your system to capture, to ingest, it is very tricky for you to say, the data that you've given me is slightly wrong. I won't take any of it. As a consequence, you might think that at the extents of your system, you might want to be very accepting of the data that you take in. And so the predicative approach that you see here may actually be something that you want to do at the extents of your system. So you don't throw away data. You don't throw away information that somebody has given you. You can at least accept it. You might just not be able to do anything with it without some human intervention. However, at the inner analytical core of your system, it's definitely the case that this kind of checking is going to get real old, real fast, and has very high risk of you forgetting to do. And as a consequence, you might think at the inner analytical core of your system, you might want this constructive approach. In fact, when we talk about data ingestion pipelines, I like this pattern a lot. I like to ingest data in an unstructured fashion, maybe using a NoSQL data source, so that pretty much anything goes. You have some information for me, I'll take it. And then when I'm going to do something with that data, I like to extract from that data using some predicates to identify, is this a correctly filled out field? Does it have everything I need? Extract that data into a better structured formulation, maybe a proper SQL database, and provide an analytical user with very clean, very rigid, very formulaic data with maybe some indication that 1% of the data got lost, got left on the cutting room floor. We just couldn't bring it into the analytical system. But ultimately, that might not affect their results, or ultimately that might just create a little bit of human manual follow-up work. I'll just go through these records and just see what's going on here and deal with those on a case-by-case basis. Also, note that when we talk about the validity of some data, we have to be very careful, because is the validity property of that data indelible? Is it itself immutable? Is it the case that what constitutes valid data today is what constitutes valid data tomorrow? And is there only one unique, privileged, otherwise unambiguous notion of validity for this data? Because if we take our star trader example and we start to extend it a little bit, you might think, well, we have our trades. Maybe we'll also include this asset here. And we construct a portfolio for each one of our traders, which is just a list of the trades. And as long as this is a list of some sort containing trade objects, this is valid. And I guess we need to identify who performed these trades, so we can do some reporting function here. So we need the trader itself. And so this is correct as long as we filled in these two fields. This is correct as long as we have filled in the price and the volume subject to any other requirements that we have. But the trader, what makes a trader piece of information correct? Well, here we're just recording their name so that we can print out this trader has this much in assets, this trader has this much in assets, this trader has this much in assets and has made this much profit. What constitutes a valid trader here? Well, if we think about this, is this just any string value? So maybe bytes values are out? Well, that's a pretty loose definition, because you can think that it's not just the case that we're going to use this for reporting purposes, in which case, for reporting purposes, we might say this should be a non-empty string, because otherwise we'll have weird lines in our report where it says blank has $2 million of market value and $30,000 of profit. It may be the case that this triggers downstream actions. Maybe we need to fill out some sort of regulatory reporting per trader. So-and-so trader traded this much on this date, and therefore they are liable for this amount of taxes. And if that's the case, that downstream system may have requirements for us. That downstream system might say, well, I'm an old COBOL-based government system. I only take names as first name, last name, maximum 10 characters each. In which case, if we don't perform the structuring on this name to break it down into first name, last name, even if that's not appropriate for our underlying user, bear in mind, that downstream system may or may not have a good notion of validity, but it has its notion of validity. And I don't know if we really want to fight this all the way to City Hall just so that we can submit some end-of-year reporting for our taxes. Well, if that's the case, you could think that this is now affected by some downstream system. And it's not just that one downstream system, it could be multiple downstream systems. Obviously, for the traders, we're going to have to feed information about them to various different entities, to whatever our space-based equivalent of the SEC is, whatever our space-based equivalent of the IRS is, whatever our space-based equivalent of our municipal government might be. And as a consequence, we might say that the correctness of this class is actually the intersection of all of those systems. Well, that's going to be very exhausting, because what really constitutes the intersection of all of the requirements for all of those systems and the naming requirements for those systems? Hopefully it's something very easy. Hopefully it's just first name, last name, middle name with a maximum length of something, which by itself is not strictly correct. Not everybody has a middle name, not everybody has a last name. But at least it's manageable in our code, and we can work around the ultimate incorrectness of this. But what if one of those systems changes? What if one system says, oh, we upgraded from our COBOL-based system to a Python-based system, and as a consequence of upgrading, we're using more memory, so we actually can only have 7 characters in the name, no longer 8 characters in the name. Those old technologies are still good for something. They're very memory efficient. And what that might mean is data that was captured at one point in time and was considered valid at one point in time is no longer considered valid at another point in time. What if the requirements for what we capture are increased? What if for some know your customer or anti-money laundering requirements, we need to have an address for these traders? And what if we need to have a designated entity that is domiciled in wherever the jurisdiction of this IRS or SEC body is, in order to be served notice if you're in violation of some compliance regulation? Well, the requirements may increase, which means old data may no longer be in compliance. It also means that data that is in compliance today may no longer be in compliance tomorrow, and it means that there may not be one singular notion of validity. Note that the constructive approach typically assumes that there's one notion of validity, and that notion of validity will always be the same notion of validity, and that notion of validity will never change. Because you can think otherwise, just because we created an object, it's not just the case that the object has to be immutable for the validity of that object to persist, but also what is considered valid has to also be immutable. And the moment you interact with the outside world, the moment you interact with the regulatory world, these regulations change, and they change very quickly. They change in ways that are very difficult to predict. As a consequence, you may actually choose a predicative approach and have a predicate for each notion of correctness, and just really be very careful to always assure that the predicate is checked prior to feeding this data to a downstream system. Additionally, you might ingest the data and have some centralized system, and then have some offshoot systems for each different subsequent downstream, which then extracts by predicate the data into whatever formulation is necessary for those downstream systems. It is not simply the case that we can say what is valid today is guaranteed to be valid tomorrow, what is invalid today is guaranteed to be invalid tomorrow, and what is valid today is universally what is considered valid. Different people don't have a notion of validity.